Now that in 4.1 we found out how to find the standard divisor and the standard quota, now we'll look at Hamilton's method, which is what do we do with that information, or how do we actually get a final number of how many representatives everybody gets? So we'll go back to some of the examples we just did. So the way that Hamilton's method works, every state gets at least its lower quota, and then as many states as possible get the upper quota. So basically until you run out of seats to hand out. And so how do you decide who gets them? Whoever has the highest, what they call residue, meaning who is the closest to rounding up. So who has the highest fractional part and who had the second highest fractional part. So if we want some nice steps for it, we figure out the standard divisor and then divide that into all the populations to get the standard quota. So then every state's got a number of seats they're supposed to get, but usually they don't divide out evenly. So to say like that one was 32.92. So everybody gets at least their lower quota. So even if your standard quota is 32.99, you might still only get 32 seats, but you could get 33. And then you give away the surplus seats one at a time to whoever was the closest to rounding up. So it's a way to give away the extra seats. Okay, then we'll look at the one where we already had numbers for it. So the Congress, where we had the 1.6 million numbers, and we did the standard divisor and the standard quota. So these are from 4.1. So we had the populations, we got all the standard quotas. So lower quota means they're going to get at least 32 seats. They'll get at least 138. Notice how we're rounding everything down. So they'll get at least 3, at least 41, at least 13 seats, and at least 19. Okay, so how do I know how many I have to give away? Well, if you round them all down, then add them all up to see how many seats you've already given away. So we've already given away 246 by rounding them down, which means we have 4 extras. Now you don't have to individually write down this line if you don't want to. They're just trying to point out what the residue means. It's the fraction part. But in practice on your paper, if you don't feel like rewriting that, you can totally look at these and say who was the closest to rounding up. Okay, so we got to rank them. 0.92 looks like the biggest decimal left over here. It was the closest to rounding up, so 0.92 is the biggest. After that, it looks like 0.82. Then it's pretty close between 0.76 and 0.72, but 0.76 is a little bigger. And then 0.72 is bigger than just 0.7, because that's 70 100ths, and that's 72 100ths. So it looks like we got 1, 2, 3, 4 ranked who is the closest to rounding up. So who gets an extra seat? It looks like A gets an extra seat, then D gets an extra seat, then F, and then B. And so picture if they were going to get at least 32, now they actually get 33. They were going to get at least 138, so now they get 139. So they get one of these extra ones. We're handing them out. And then here they were going to get at least 41. They get an extra one, so they get 42. And they were going to get at least 19. They get to round up with 20. And the ones that had the lower decimals or the lower residuals or weren't as close to rounding up, once you run out, then they don't get any extra. And so then picture that gives you a way to check at the end that it perfectly adds up all these seats to 250. So you gave away all 250 and you figured out who got the extra ones in a systematic way. So this was a method come up with during that same problem when they were trying to hand out representatives by Alexander Hamilton. So it's just a way to give away the extras. And so just a little historical kind of footnote on this. Hamilton's method is still used today in some other countries. And I think this was 2014. So as of 2014, Costa Rica, Namibia, Sweden, all use Hamilton's method. And it's good. The only flaw, or, the major one, I guess, that stands out here, it's not something you think about when you're doing it necessarily, but is if we are comparing how close they were to rounding up. If I look back here, The reason that this one rounded up is because it was 0.92. It had the highest residual. But remember, that's 0.92 of maybe a small population, and the other one might be 0.72 off of a bigger population. And so it doesn't take that into account because you've already just said, okay, how close were they to getting another seat? But in general, it's a pretty good method. And one other thing this method has going for it is that it's easy to understand. You just give everybody their lower amount and then decide who gets the extras. And it also satisfies what's called the quota rule. So the quota rule says that no states should get lower than their lower quota or higher than their higher quota. So whatever you're doing, if you get 32.92, they could round down to 32 or up to 33, but you shouldn't do a method that gives them a completely different number than that. And so you notice here, we round everybody down, they might get one more seat. It doesn't give you a value that's lower than your lower rounding down amount or higher than your upper rounding up amount.